All right, tonight we're going to continue our examination of the diagramming of formal propositions and tonight our specific concern will be to move ahead to deal with the diagramming of the formal categorical syllogism. Now, everything that we've been doing so far has been leading up to this exercise tonight, and so I hope that you're all fresh in your minds and have mastered the preceding material so that we can move ahead into this dimension. All right, the last time that we met, we dealt with diagramming propositions, and we dealt with the business of doing them in terms of two circles. Now, tonight, in order to get the complete diagram for the diagramming of a syllogism, we need to have three circles. And the reason for that is obvious, because a syllogism contains three parts, the major and minor premise and the conclusion. So rather than two overlapping circles, we need three overlapping circles. And for those who are listening to this by tape, rather than observing it visually, if they would think of the emblem of the Olympic Games or of Ballantine beer, perhaps they'll be able to reconstruct the three circles that intersect with each other. Now, the three circles represent the three parts of the syllogism. The upper left-hand circle will indicate by the letter S, because it stands for the subject proposition or premise. And this top right-hand circle we will call the P circle, standing for the predicate. And the third circle that we add, intersecting the other two, is the M circle, representing the middle term. So the quotient that we're dealing with in the three-ringed circle is not SP, as we dealt with in terms of the diagramming of propositions, but rather the full quotient SPM, subject, predicate, and middle term. Now, this three-ring circle represents 8 different formal classes. 8 classes. That is, there are 8 possible relationships between subject, predicate, and middle term when we're dealing with categorical syllogisms. We have the SPM, where there's a full involvement of S, P, and M in relationship to each other. If we have a situation where, or a part of the premise that involves S without any P or without any M, we would state S, non-P, non-M. We can have a class of a relationship between SP, non-M, between non-S, non-P, and M, as you will see, and all of these add up to 8. Now, it's hard to understand that by just stating it abstractly. And so if you're confused at this point, I'm not surprised. But I think that it's easy to understand it if we can visualize it by looking carefully into the cassette recorder to see what you can see, but into the three diagrams. If you see the three circles and look at their points of intersection, we have in these circles, as they intersect, how many distinct areas? 7. And 1 makes how many? Where do we find the 8th distinctive area? Everything outside of the circles. See? Now, I'm going to show you what I mean by these 8 classes quickly. Again, the 3 circles represent circle S, circle P, and circle M. Now, that part of circle S that represents, let's put it this way, that intersects not at all with either P or M. That part of circle S that is totally outside of the other two circles, we would state as representing S, non-P, non-M. That would mean all of S, which is not contained in or part of P or part of M. Is that clear? All right. Then, how would we state that part of P, which is totally outside of the circles S and M? How would we state that quotient? We would put non-S, P, non-M. All right. Now, coming down to M, how would we state that part of the circle which does not intersect or is part of any part of circles S or P? How would we state that? Non-S, non-P, M. Very good. Now, how would we state that part of circle S that is also part of circle M, but not part of circle P? S non-PM. Thank you. Now, that part of circle P, which is part of circle M, but not part of circle S. Non-S, P, M. Now, we have one little part where all three circles intersect. Right here in the middle. How would we state that? SPM. How about the part where S and P intersect but do not intersect with M? SP non-M. And the one other section is outside of all the circles, and how would we state that? Non-S, non-P, non-M. All right, do you get the hang of that? All right, now we're ready to move into our diagram, which is the test for the formal validity of syllogistic statements. All right. Let's just do an abstract syllogism as an example of how this proceeds. Let's take the following syllogism. All M is P. That's the first premise. All S is M is the second premise. The conclusion is all S equals P. Is that clear? All M is P, all S is M, all S equals P. Now here's how we test the validity of the syllogism by the use of these diagrams, these Venn diagrams. We begin by, first of all, putting our three circles on the board and diagramming the first two premises. Not diagramming the conclusion. We're only going to diagram, by use of shading or X's, as we've demonstrated before, the first two premises. Now, using the diagram, how do we shade the three circles to indicate the statement or the proposition, all M is P? All M is P. How do we shade that?
Shade all of them except S, non-P, N, and SP.
shade all of M except what?
S non-PM area and SPM area. No, I'm sorry. SPM area and non-SPM area.
Okay. I'll make a step. In other words, what we're doing is shading all of M that is not P. All right? So that all we have left of M is that which is contained within P. Right? Now, all S is M. What do we shade of S? No. Everything but that little part that's left. Because this is the part of S that is M. You see? Here's where S intersects M. Up here is outside of P, and it's outside of M. So we shade everything that is outside of M, which leaves us, in this case, a little island. Now, we have shaded in the circles, therefore diagrammed the first two propositions. Now, here's how we test whether or not the syllogism is valid. Whether or not, by diagramming the major and minor premises, we have already, in fact, diagrammed the conclusion. If further shading is necessary, then we have an invalid syllogism. Now let's look at what we have left. All S is P. Does that show on this diagram? Is there any diagram, is there any part of the circle S that is not shaded in already, that's not P? Yes, because we shaded it wrong. You've got to be careful when you do your shading, or you'll have an invalid syllogism. There's where our island should be. See? All S.
No, you got it right the first time. Yeah, the first time.
First time it was right. Oh, yes. Is all of S that is left P? Yes. It's M2, but it's still P. Okay? We don't have to shade that in any further. Now, to make this clear, I'm not going to just go too quickly with you. We're going to do the same thing now with an invalid concrete syllogism. Let's take these statements. All dogs are mammals. All dogs are mammals. Second premise, all cats are mammals. You ready? Therefore, all cats are dogs. What is the subject term of the syllogism? What is the subject term of the syllogism? How do we learn the subject term of the syllogism, Mr. Rink?
Subject term of the syllogism is
You're right so far.
yeah. subject of the major premise.
No, it's not the subject of the major premise. That's where we get confused, you see. It's how do you find the subject term of the syllogism?
Appears in both the major premise and conclusion.
Yes, it's the subject of the conclusion. And how do we find the predicate term? By looking at the predicate in the conclusion. And what's the middle term? It's the one that's left. Right? So how do we state this syllogism? How would we first of all, translate the statement, all dogs are mammals, into our symbols here? Is dogs the subject or the predicate? Right. What's the middle term? Mammals. So it's all P is M, and all S is M, and the conclusion, how do we state the conclusion? All S is P. Got that? Now let's test it with the three circles. All P is M. What do we shade? Everything outside of M and P. Everything in P that is outside of M. All right? Is that right? Okay. And the second statement, all cats are mammals. How do we translate that? All S is M. So what do we shade? Everything it's S that's outside of M, right? All right, you got that? Now, what's the conclusion? All S is P. For me to demonstrate that diagrammatically, would I have to do any more shading? Yes, I would have to shade that part of circle S which is still outside of circle P. So more shading is required, and what does that mean? It's an invalid syllogism. Ready? Now let's continue. Only now moving to universal and particular premises, where we don't have all universal premises, where we use I statements and O statements, as well as A and E propositions. Now, here's some basic rules for diagramming syllogisms that contain both universal and particular premises. When you diagram, you always begin your diagram with the universal statement. All right? Here's our syllogism. All artists are egotists. All artists are egotists. Some artists are paupers. Therefore, some paupers are egotists. All artists are egotists. Some artists are paupers. And some paupers are egotists. What's the subject term? All right. Paupers is the subject term, so we would use the symbol S to represent the term paupers in the syllogism. What's the predicate term? Egotists. And so we would use the term P for the egotists. What's the middle term? Artists. All right, now before we diagram this and go over this business, let me just take a straw vote here and say, how many of you think this thing's a valid syllogism? 1, 2, 3. 1. How many think it's invalid? 1. How many didn't vote? Okay. All right, let's look and see if it's valid. Let's unravel the mystery. All right, so if artists is the middle term and egotists is the predicate term, and the first term is all, goes like this. All M is P. What's the next term? How do we state some artists are paupers? Some M is S. Good. Okay. And how do we state a conclusion? Some S is P. Got it? All right, now let's do the circles. First thing we do is which one? All right. All M is P. So all of M is P. How do we shade that? What do we shade out? All of M that is outside of P. Is this part of M outside of P? All right. Is this part of M outside of P? All right. How about this? Huh? Okay. So all that's left of M is that which is in P, right? Now, some M is S. Some M is S. I have a problem with my circle. I haven't intersected all three. See that? Some S is P. Is that true? Where are we? We're on this. I'm sorry. Some M is S. Is there any M there that is S? Where is it? It's where all three circles intersect. Now, how do we indicate a particular statement here in the diagram? Do we shade? What do we use? Yes, we put an X in here. indicating that part of M which is also S. All right? Now, look at the conclusion. Some S is P. Is that true? Okay. Do we need to do any more shading to indicate that? Or do we already have some S indicated as appearing as part of P? Yeah, so we don't need to shade anymore. Or X anymore. So we have a valid syllogism. Now, some of you thought it wasn't valid. And I'd like to pursue that for a moment here and ask you why you thought it wasn't valid. You must have had a reason. You just intuitively felt that it wasn't sound. That's okay? That's good enough for me. Anybody else have any other reasons why they thought that perhaps this thing would be invalid? Is there anything you don't like about that syllogism? Do you agree with the conclusion that some paupers are egotists? Think that's true? How do you like the major premise? All artists are egotists. Is that true?
Probably not.
It may be. But let's suppose that we could find a, say, one artist at least that was not an egotist. Would that destroy the formal validity of this syllogism? No. It would destroy the material validity of the syllogism, but not its formal validity. You see, the test of the validity of the syllogism that we're working with here in terms of the Venn diagram only tests the formal truth of the relationship between the premises and the conclusion, to see whether or not the conclusion is legitimately drawn and inferred from the premises. It does not test the material truthfulness of the premises, which depends for their verification on induction rather than deduction. But given the truthfulness of the first two premises, we can validate or invalidate the conclusion, do you see, formally. Now let's take another syllogism that contains a universal and a particular premise. Here it is, as I set it up before you. All great scientists are college graduates. Some professional athletes are college graduates. Therefore, some professional athletes are great scientists. All right, let me give you those again. All great scientists are college graduates. Some professional athletes are college graduates. Therefore, some professional athletes are great scientists. What's the subject term? Professional athletes. What's the predicate term? Great scientists.
What's the middle term? College graduates. To set it up, let's do it this way. Where do we start, Paul?
Universal.
With the universal. And how would you state the universal here?
All P is M.
All P is M. How would you state the second premise? Mm-hmm.
Some S is M.
Some S is M. All right. And how would you state the conclusion? Some S is P. All right. Anybody want to venture a guess before we start as to whether or not this is going to be valid or invalid? Mr. White? It's wrong. Why is it wrong?
Because some professional athletes or college students can be drawn from a population not of the college graduates that are great scientists. In other words, all great scientists are college graduates doesn't cover all those who are college graduates. Therefore, you could draw some professional athletes who are college graduates who aren't
Great scientist, right?
well, the way I just stated it is wrong.
All right. You sure it's wrong? You seem hesitant.
I wouldn't stake my life.
All right, well, let's get it to where you can stake your life on it. All right? See, that's where, you see how easily you can get confused in these things. And this is the value of making it concrete, of being able to see it as well as to think it through and to test it this way, right? You ready? Do you have a question?
Yeah, I'd like to venture a guess.
Okay.
Either being valid or it could be valid or invalid. Either one.
It could be valid or invalid, either one. Good guess. Let's see. All right?
Now, let's take our 3 circles, 3 rings for Ballantine. S, P, M. All right, let's take the first statement. All P is M. So what part of P do we shade? All of P outside of M. Okay. Second statement, some S is M. Where do I put my check mark? Where S intersects with M. Why?
Well, you haven't said anything yet about some S being P.
All right, but do you see that there are 2 possible areas here, Bill, where I can put an X for S and M. In this area here, S and M are together. See that?
Yeah, but what you're trying to find out is if some S is P, so you can't put the X there right now.
Now, wait a minute. So, but is it true that this represents some S as M? Does this represent some S as M? So why should we put it in the one rather than the other? Is there any compelling reason to put it in one or the other? You cannot consider the conclusion at this point, or you invalidate the test, you see. Is there any compelling reason to put the X in one side or the other? Well, we have to indicate that part of S that is also M. It could go either place, couldn't it? Huh? And the only way to put it in one or the other is by an arbitrary methodology, just taking your pick. But you can't do that in Venn diagrams. We have to indicate in our diagram the indecision at this point by placing the X on the line that intersects the two possible zones into which we could put it. By placing the X between the two areas, thusly. All right? Now, let's look at the conclusion. Sum S is P. What's the problem? You have to do the same kind of thing. You would have to indicate an indecision in the thing. Now, does that mean that the statement, the syllogism, is valid or invalid? What was your thing again, Paul?
It can be both. It can be one or the other.
All right, I said that was a good guess. It could be one or the other. But that's not the answer. That's not true. It can only be one. Which is it, valid or invalid?
Invalid.
Why?
Because you're trying to establish a proof, and you can't establish a proof on something that's uncertain.
That's right. The question is whether or not the conclusion can be logically inferred, you see, by compelling force of logic from the first two premises. And it cannot in this case. The statement may be formally true. I'm sorry, in this case, the syllogism, the premises and the conclusions, and the conclusion and all of the premises may be materially true, but not formally demonstrative on the basis of this syllogism. The last syllogism we examined was formally true, but materially false, according to our, that is, if we could find one artist that was not a negotist. You see. In this case, we have one that could possibly be true. That is, the conclusion could be true, the premises could be true, but what makes it invalid is that the conclusion cannot be logically drawn by logical necessity from the premises. Do you see that? Is that more clear to you now, Dr. White, than it was before we put it on the blackboard? Okay. Fine. Now what we've done here is that we've just simply analyzed different types of syllogisms. There are a lot more that we can do, and what I'd like to do with the time that is left is simply learn by repetition, by practicing. See, it's still obvious that it's not clear and certain to you. So let me give you a few more examples and let you work them out. Are you ready? All minors are strong. All right? All golfers are strong. Therefore, all minors are golfers. All right, how would we state? First of all, let me back up a minute. What's the subject term? Minors. What's the predicate term? What's the middle term? Okay. Let me ask one of you to come up here and diagram this for us. I'll narrate it for the value of those who aren't here, but I'd like you to work it out rather than have me just ask you in the Socratic method. Paul, are you ready to try one?
Yeah, what do you want me to do with it? Just
I want you to diagram
circle
it.
it?
I want you to diagram it. Okay. All right, he's putting 3 circles on the board, intersecting themselves, somewhat elliptical, oblate spheroids, is S, P, and M. All minors are strong. What's the, how would you state that, all what is what?
All S is M.
All S is M. Fine. Okay, how would you shade that? Okay. Second statement, all golfers are strong. That's all P is M. And how would you indicate that? All right, he's indicating that by shading everything in P that is outside of circle M. All right, now what's the conclusion?
All S is P.
All S is P. Would you have to shade anything out to indicate that?
Yes, you would.
What part?
This area right here.
All right, so what does that mean?
It's an invalid syllogism.
It's an invalid syllogism. Okay, very good. Does everybody see that? Hmm? Okay, let's do one that has a universal and a particular. See if this helps. Some men are black. Okay? Some men are not black. Therefore, what? Some women are black. Who wants to tackle this one?
Already in there.
You've introduced a fourth term.
What's the fourth term?
Woman.
Mm-hmm. Can we do it?
Not unless we establish the necessity of some women being black because some men are black.
All right, see if we can set this up in syllogism form.
You have a different term than S, P, and M unless you equate, unless you equate women as S, and if you equate men as S, also that's the only way you can do it.
If you equate men and women as S. All right. Can we come to this conclusion that some men are white?
Can't do that either.
Why not?
Because black doesn't necessarily mean white.
Okay. Now, how about if we do this? How about if we take all men are black? Make it that. All right. Some men are not black. Then can we go some men are white?
No? Well, you can probably do it formally, but your statements are contradictory already.
Why are they contradictory?
Well, you're saying that all men are black, and you're saying some men are not black. You have a fundamental contradiction right there.
But can we show that?
But you can.
Are you sure we don't just have a paradoxical antinomy here?
I have one of those too.
All right. Let's try to diagram it. First, we begin by looking for the predicate term. What's the predicate term?
White. Well, see, again, you've got...
P stands for white.
Black to white in your minor premise in order to make...
All right. What are we going to do with what's the subject term? Men is the subject. What's the middle term? Is black common to both? But in one case it's negated, in another case it's affirmed. Huh?
Trying to take black and non-black and mean the same thing.
That's right.
Non-meaning the same things in the tongue.
Yeah. Can we do that?
No.
Why not?
Again, you're violating the law of non-contradiction.
Yes. All right. So we really have 4 terms rather than 3. So it can't be done. Now let's do another one, or try to do another one. All birds are red. Okay? Some cats are red. Therefore, some birds are cats. There is a catbird, you know. All right, Dr. White, would you like to do this one for us, or just I'll just ask you to answer the questions for me. First of all, what's the subject term?
Birds.
All right, birds is the subject. What's the predicate? Cats is the predicate. And what's the middle term? Red. All right. All right, so we state it all S is M. Some P is M, and the conclusion, some S is P. Now, for the circles. All right. How do we, where do we start, Dr. White?
Universal.
With the universal. All S is M. How do we indicate that?
All S outside of M
All S outside of M
shaded.
is shaded. All right. Some P is M. How do we do that?
So if you have to put another X on another line, because
two possible areas where P is M, right? So we have to put an X on a line. Look at the conclusion. Sum S is P. Would we? How much of S is part of P? Two areas? Where are they? Here's all we have left of S. Is this part of S part of P? Is this part of S that remains part of P? So we couldn't put it there, could we? How much of S is left that's part of P? You said you have to do the same thing. You mean put it on a line between two places?
All that's left is where all three intersect.
Where all three intersect. Would I have to put anything there?
It still seems to me that you put it on the line.
Why? The line between what?
The line that passes through the middle of the larger section where S intersects with P.
Here, you mean? Here. This has already been blocked out. That's all we have left. Is it possible that we could shade this in had we elected to put the X over here? The point I want to get at, Bill, is that there's only one area left where S and P could possibly be together. And an X does not occupy that spot. It occupies the line between P and M. See? So even though we don't have two areas left in the conclusion of uncertainty like we did in the second premise, we still have an invalid syllogism. Right? Because we would still, at least theoretically possibly, have one circle left in which to shade, had we put this X over here. Do you understand that? In other words, what I'm getting at is that we know that it's invalid already from the second premise. Having to put that X on the line makes that particular statement invalid. That's why we had to put it on the line, because had we arbitrarily placed it up here, then we wouldn't have had to shade in anything at all with the conclusion, thereby making the syllogism valid. Do you understand that? What I want to get you away from is the idea that it's only invalid if there's two places left in the conclusion, as there was in the second premise. If there's two places of equal opportunity in the second premise, or even in the first premises, as far as that goes, they cannot be exactly shaded or X'd, you know already that the thing is invalid. All right, let me stop at this point and commend to you further practice on your own as you work with these diagrams. The next time that we meet, we will, which will be the last time that we meet, we will deal with additional rules of formal logic, just supplementary rules that we can draw from the things that we've worked on so far.